Hello friends, Leonard Euler here. I want to tell you about this mathematical puzzle. There are a lot of legends about this puzzle, and it includes the famous mathematician Leonard Euler. It took place in the town of Koenigsburg, and there was this river running through it, and there were 2 islands, and there were 7 bridges. There were stories that the people used to walk around on Sundays, or that they wanted to have a parade or something, but the idea was basically this. They wanted to cross every bridge once and only once, and see if they could do that without having to jump into the river. Leonard Euler somehow heard about it, or he went to the town or something, and he was able to figure out what was wrong, and in the process also invented a whole new branch of mathematics. Let's take a look. In the town of Koenigsburg, there was a landmass here and a landmass here, and 2 landmasses in the middle of this river, and there were 7 bridges. You can see them here. Now, if we start anywhere and end anywhere, without jumping into the river, we can go across like this, whatever you want to try. But now at this point, either we have to go across that bridge or this bridge, and there's one left uncrossed. And so the people were trying to figure this out. One of the things that mathematicians and scientists try to do is they simplify. It's really difficult to try to draw this every time, so we're just going to simplify. What we'll do is have each landmass represented with a point, and we'll connect the points with lines, and the lines represent the bridges. So what do we have here? We've got 1, 2, 3, 4 landmasses, and between this landmass and this landmass, there's a bridge. Between this landmass and this landmass, there are 2 bridges, right, etc. So the whole thing can be simplified down to look something like this. Right? Here are the 2 mainlands. Here are the 2 islands. This island had 5 bridges on it, right? You can see that here. This one's got 1, 2, 3, 4, 5, etc. All right. And so then we can makes it a little bit easier for us to analyze this and see what's happening. We see that we have these points, and we have lines coming out from each point. And we see that here there are 3, 3, 3, 5 lines coming out from these points. And here's where things get interesting. What we can do is we can ask ourselves, well, what does it mean if we have 3 lines coming from this point? You know, for example, if I start at this line and I go out from it, whatever else happens over here, at some point I have to come back to it and then away from it. That means if I start here, I have to end somewhere else. And that is going to hold true for any odd node. Right? So if I have an odd node, that means if I don't start here, you know, for example, I come here and then I have to go away and then somewhere else, eventually I'm going to have to come back. If I don't start at this point, I have to end at an odd node. For this even node, so any point that has an even number of lines coming to it, if I don't start here, then I can come and go away and then come back at some point and go away again. So for an even node, I don't have to start at that node. I can start and end away from it. Right. And so what I realize is that if I have odd nodes, I have to start and end at those odd nodes. And that means I can't have any more than 2 odd nodes. And so here, the Bridges of Koenigsburg, again, I see that I have all 4 nodes are odd, and so this is simply impossible. It can't be done. And then this invents the whole mathematical branch called networks. And maybe you've seen puzzles like this one. The challenge, can you go over every line once and only once without taking your pen off the paper? Well, here's the trick to this. You find the odd nodes, and you know then that you have to start and end at these 2. You could start at either one, end at either one, but as long as you do that, you should be able to do this. And you can get these on the first try. So for example, I'll just start here and then go out away like this. Just like that. Start and end at the odd nodes. However, if we were to take away this middle line, and then we have something like this, and this can't be accomplished.